Hello, in this video we will compare the relationship between power series and logarithmic regression. We'll generate the dataset of power series or the logarithmic over the values of x from 1 to 10 and the power series also using exponent a as a coefficient and b. So we begin with the coefficients. So that data validation, use a list from 0, 1, 2, 3. And our B will be also, we choose small values. Data validation of a list from 0, 1, 2, 3. But you can change that. So for A, you have 4 values to choose from. And B, you also have 4 values to choose from. Then we generate the logarithmic regression, which is array formula of a plus b ln x. A plus b times ln x. And we choose value for, let's say 1. So you have about. Then we calculate the exponent. So exponent a. Now we can generate the power series regression. So array formula of a exponent a times x to the power b. Exponent a times x to the power b. X to the power b. And we'll graph this in a scatter chart. Insert chart. We'll use scatter chart. And assign trend line. For the logarithmic, we will use the logarithmic trend line. And show the equation. So it is y equals a plus b ln x equals 1 plus 1 ln x, which is a and b. For the power series, we will use the power series trend line. And we'll show the equation. So we have 2.72 times x to the power 1, which is also our exponent is 2.72 times x to the power 1, our b. Our b is 1. If we change our values to 2 for a, you have 2 plus 1 ln x, and you will have the power series as 7.39 times x to the power 1. If we change that to 2, now you have this value. But the value of the logarithm cannot be seen. So we will change the scale of our vertical axis. The vertical axis will use the log scale. Now we can see the trend line of the logarithmic scale, the logarithmic regression. So we'll set this aside and enter the rest of the if we change this to 3, that's now 7.39 times x to the power 3. Our logarithm will be 2 plus 3 ln x. And if we change that to 3, you'll have 3 plus 3 ln x, 20.1 times x to the power 3. Next, we enter the 1 comma x matrix, which is equal to array formula of the x values raised to the power 0. So we have the 1 column. Then the ln x column, which is array formula ln of the x values. Now we can use linest and the logest. So enter the linest first, linest of the y values and the ln x values and show the full statistics. So our value for A is 3 and our value for B is also 3. We change that to 2. So our value for B is A is 2 and value change that to, let's say, change it to 1. So that's our B is 1. Next we use the logest. This time we'll use this on the power series. So logest of exponent y and our data x will be ln x. And we'll show the full statistics. You will notice this is exponent a and this one is exponent b. The exponent of 1 is 2.71828. Our value for standard error, they are all 0. Our value for r square and stay x, they're the same. Our value for f statistic and degrees of freedom, they're the same. And the value for the regression sum of square and residual sum of square, they're the same. You can use 3 here, and our exponent a is 7.39 times x cubed, and our ln logarithmic regression will be 2 plus 3 ln x. This shows the difference between the logarithmic regression and the power series regression. They're actually the same. They just happen to be on a different scale.